Good afternoon, our audience, and welcome to this afternoon's class. Today, we have come to solve with you some questions drawn from some exam bodies, especially as it concerns JAM and the screening of different universities. These questions, of course, border on square roots, just square roots. However, they are questions that could be very, very strange and challenging most of the time. So we are going to look at questions that just border on square roots. So permit me to divide this board and recall for you something before we progress. So if I divide this board this way, I have this way. Then I have square roots. Square roots. Of course, the symbol of square roots in mathematics is written like this. This is the symbol of what? Of square roots. So ordinarily, if somebody say, what is the square root of what? 4, for instance, you are going to write that square root of 4 is given this way. And of course, you are looking for a number that you multiply to itself to give you the value of what? Of 4. And that number becomes this plus or minus what? 2. If you talk about square root of 9, you are equally going to write something like this, square root of 9. Then you equally look for a number that you multiply to itself to give you what? 9. That number is what? Plus or minus what? 3. It is plus or minus here because if you say plus 2 times plus 2, the answer is 4. And if you say minus 2 times minus 2, the answer still remains 4. The same thing applies over here. If you say plus 3 times plus 3, the answer is what? 9. And if you say minus 3 times minus 3, the answer becomes minus. Because that minus multiplying minus changes the sign to what? To plus. This is something that you know, which is common in mathematics. However, we have questions that are bordering on square roots, which are very challenging. We have them here so that at the end of it, we must avail all the students who are preparing for JAM or preparing for screening of different universities or even for other higher examination bodies must have equipped themselves on how to go about solving problems like that. So permit me to call up the questions at the other side of what of the board while we solve this side. The first question says, and I write. So that is question number 1. That number 1 says, what is the square root? What is the square root of 8 plus 2 root 15? That is what they ask us. What is the square root of 8 plus 2 root 15? So as a word of solution, I'll come here and write solution. When we were asked earlier to find the square root of 4, we began by using the square root sign to enclose what? 4. So I'm going to do the same thing with that because I was equally asked to find the square root of that. So the beginning is going to be that thing becomes square root of what? Open a bracket, 8 plus what? 2 root what? 15. That is the first thing we are going to do. The next thing you are going to do here is, I advise that you first of all handle this root 15 by bringing out this what? 15 and trying to break 15 into what? Into 2. Breaking it into 2 here, I mean is that you come out here and write 15. You have 15 this way. This is 15. And then you ask yourself, aside 1, what is another number that can divide 15 without remainder? That number is what? 3. Because 2 cannot divide 15 without remainder. So which means if you write 3 here, you can equally say 15 divided by 3 will give you what? 5. So by implication, 5 times 3 is 15. So I'm free to revert back to this question, and wherever place I see 15, I am free to use 5 times what 3 in each place. And if you agree with me on that, what I'm going to have here becomes that this thing becomes what? This becomes what? Root of what? 8. This 8 here, open a bracket, plus. Here is my 2, then I'll now open a bracket. Instead of writing 15, I'm going to write 5 times 3. I'll close the brackets. Because this 5 times 3 is the same thing as what? As a 15. That taken care of. Then we now move ahead again. Remember that in surd, whenever we have root of A times B in surd, it can be written equivalently as root of A multiplied by root of what? Of B. If you agree with me on that, it implies that root of what? Root of what? 5 times what? 3 is going to be what? Root of 5 times root of what? 3. So I'm free to come back to this question. Wherever place I see root of 5 times 3, I'll use root 5 times root 3 in each place. And therefore, this thing is now going to be square root. Here is my 8, I'll write my 8 plus. Here is my 2, I'll write my 2. Instead of writing root 5 times 3, I am going to write root of what? 5 times root of what? 3. Then I'll close what? The brackets. Then we ask ourselves the next question. What I have here is 5 and what I have here is 3. I will now try to come back to this 8 now and break this 8 into what? Into 2. Making use of what? 5 and what? 3. You know that 5 plus 3 is what? Is 8. So I can come in place of this 8 now and write 5 plus 3. So in that case, what I'm going to have becomes that this becomes square root. In place of this 8, I am going to write what? 5 plus what? 3. Because 5 plus 3 is going to give me 8. The sign here is plus. So I have plus. What I have here is what? 2. I have 2. Root of what? 5 multiplied by root of what? Of 3. I will close the brackets. I will close it this way. Now, this appears in the root. This appears in the roots. I can try and convert everything inside this place to appear as what? As roots. Such that if I come to this 5, of course you know that there is no difference between 5 and root 5 all raised to power what? 2. There is no difference between this and this. This and this are the same thing. So I can decide to come back. Anywhere I see what? 5, I am going to use what? Root 5 raised to power what? 2. And anywhere I see 3, I'm going to use what? Root 3 raised to power what? 2. So in that case, what I'm going to have here becomes, I now have general square root here. In place of this 5, what I'm going to have is what? Root what? 5 all raised to power what? 2 plus. In place of 3, I'm going to have what? Root of 3 all raised to power what? 2. The sign I have here is what? Plus. I have what? 2. Here is my root what? 5 multiplied by what? Root what? 3. This and this are the same thing. Very much well. Because this and this are the same thing, the next thing we are going to ask ourselves is this. In mathematics, is there anything that is similar to what we have inside this square root? We remind ourselves something. We now say, recall that whenever we have A plus B all raised to power 2, A plus B all raised to power 2 can be expressed in mathematics as A raised to power 2 plus B raised to power 2 plus 2AB. This is how we can express this in mathematics. Let us compare this with what we have inside the brackets. I have A raised to power 2 here, just like I have 5 raised to power 2. Here is plus, here is plus. I have B raised to power 2, just like I have root 3 raised to power what? 2 inside the bracket. Here is plus, here is plus. Here is 2, here is 2. Here is A, just like I have root 5. Here is B, just like I have root 3. So it implies that what I have inside this square root can be written as that my what? My root of what? 5, root of 5, all raised to power 2, plus root of what? 3, all raised to power what 2 can be written plus 2 root 5 multiplied by root what 3 can be written as, you open a bracket, you have root what 5 plus root what 3, you close the bracket, all raised to power 2. Just like what I had here, a plus b all raised to power 2. By implication now, it means I can use this and this interchangeably. Anywhere I see the whole of this, I can use this because they are the same thing. Therefore, this thing is now going to be, therefore, what I have now is square root of. Instead of writing the whole of this, I am going to write this because they are the same thing. I'll open a bracket and write root what 5 plus root what 3. I'll close the bracket, all raised to power what 2. And you know that once you take the square root of anything that is square inside of it now, it is going to return back what you just have there under. That is to say, that whenever you have square root of what x raised to power 2, the answer is x. Square root of what b raised to power 2, the answer is what b. So as well you have square root of root 5 plus root 3 all raised to power what 2. So the answer is going to be what? Root what 5 plus what root what 3. And this becomes the answer of you getting the square root of what 8 plus 2 root 15. You see how this problem can be tackled. Okay, so I believe you have not had much problem. If you have, please drop your worries in the comment section. Once we come across it now, we will definitely attend to it. Let us call up again a similar question to this. Solve it. By solving it now the second time, we must have now deepened your understanding of how to go about solving this kind of problem. So permit me now to clean this board now. Call up now question number 2 and solve it the same way. So permit me to clean. So I'll clean this one. That question number 2 says, and I write. Question number 2 says, and I write. That is question number 2 says, simplify. Simplify root 11 minus 2 root 30. See the kind of problem they asked us to simplify. It is just on square roots. But they are not like ordinary square root we know. So we have to apply some kind of techniques to be able to come out of it now successfully. Following the same pattern like the first one we did, we now move together. That question, I'm now going to say this is solution. I also encourage you to bring out this 30 and first of all, break 30 into what? Into 2. To break into 30 into 2, what I'm going to do is this. I'll come here, I'll write 30 here. I'll ask myself, aside from 1, what is a number that can divide 30 without remainder? That is 2. I'll now write 2. 30 divided by 2 is what? Is 15. There is also another number that can go into what? Into 15 without remainder. And that number is what? 3. So I'll now write what? 3. I say 15 divided by 3 is what? Is 5. So by implication now, 30 is the same thing as 2 times 3 times what? 5. Which means I have that my 30 now, 30 equals 2 times 3 times 5. Which can be written as 2 times 2 is what? 6 times what? 5. So anywhere I see 30, I am free to use 6 times 5 there. For that reason now, I will return back to this problem. Anywhere I see 30, I'm now going to replace with what? 6 times what? 5. And in that case, that problem becomes square root of, what I have here is square root of what? 11 minus what? 2 root what? 30. It's going to be the same thing as square root of what? 11 minus what? 2 general square root of 6 times what? 5. They are the same thing. And like I earlier had said, if you come to surd, if somebody says is surd root of A times B, the answer is root of A multiplied by root of what? Of B. So I can easily come here now. I have a general square root of 6 times 5 here. I'll come here and replace it with now root 6 times what? Root 5. And then what I now have is now going to be, I have a square root of, what I have here is what? 11. What is here is what? Minus. What is here is what? 2. Instead of writing the general square root, I am going to say root 6 times root 5. This and this are the same thing. Now, the next thing I'm going to do is to break this 11 now into 2, making use of 6 and 5. Just like I broke the other time 8 into 2, making use of 5 and 3. Because you know that 6 plus 5 is what? Is 11. So in place of this 11, I am going to use 6 plus what? 5. And in that case, the whole of this thing becomes general square root. In place of this 11, I am going to write what? 6 plus what? 5. The sign here is minus. What I have here is 2. I have root 6 by root 5. This and this are the same thing. Here, this appears as root 6. This appears in what? As root 5. I ask myself a question. Is there a way I can convert 6 into root without changing its value? And equally convert what? 5 into root without changing its value? The answer is yes, there is. Because there is no difference between 6. 6 is the same thing as root what? 6 all raised to power 2. And then 5 is the same thing as root what? 5 all raised to power what? 2. So I'm going to apply that principle here. By applying the principle here, what I'm going to have here becomes, I have general square root. Instead of writing 6 here, I'll write its equivalent, which is root what? 6 all raised to power what? 2. The sign here is what? Plus. Instead of writing 5, I'll write its equivalent, which is root what? 5 all raised to power what? 2. The sign here is what? Minus. What I have here is what? 2. And then what I have here becomes what? Root 6 times what? Root what? 5. Then I ask myself the next question. The next question I'm going to ask myself is there any expression in mathematics that is close or is the same with as what we have under this square root sign? Yes, there is. In mathematics, we have that. Whenever we have A minus B, all raised to power 2, the answer is what? A raised to power 2 plus B raised to power 2 minus 2AB. This is true in mathematics. Then let us compare this with what we have under here. This is A raised to power 2, just like I have root 6 raised to power 2. This is B raised to power 2, just like I have root 5 raised to power 2. Here is minus, here is minus, here is 2, here is 2. Here is AB, which is coming from here, which here is root 6 multiplied by root 5, which is coming from here. So in that case, which means it implies that what I have under this square root can be written as that this is open a bracket, here is my A. I am looking at now A as if to say it were root 6. So I have root 6. Root 6. Here, what I have here is what? Minus. I will now be looking, here is B. I'm looking at B as if to say it were root 5. So here is what? Root 5. So I will now say this is raised to power 2. This now can be expressed as root what? 6, which is just like this A, all raised to power 2, plus root 5, which is just like this B, root 5, all raised to power what? 2, minus. Here is what? 2, root what? 5, root what? 2 root 6, root 5. So it means that everything I have under this square root, I can use this in place of it. And for that reason, I'm going to say that therefore, what I have now is square root of. Instead of writing the whole of this which I have here, I'll write this one because they are the same. So that this can be expressed as this. And the whole of this is what I have under here. So I can use this one here. So what I have becomes square root of what? 6 minus square root of what? 5. All raised to power what? 2. And of course, you know that any day you have root what? X raised to power 2. The answer is what? X. If you have root what? Y raised to power 2. The answer is y. It implies that whenever you have now, once you have square root of root 6 minus root 5 all raised to power 2, the answer is going to be root what? 6 minus what? Root what? 5. And this becomes the answer of what we are looking for. This is how to handle this kind of a problem. These problems are very familiar in some examination bodies. And without you remembering this principle, you may not be able to solve it correctly. So thank you very much for giving us your audience this morning. We keep to bring up questions from JAM, from Waec, from screen examinations, and from other higher level examination bodies to solve with you, making sure that once you go for that kind of exam, you come out very glorious. Remember to subscribe to our YouTube channel so that you can get notification once we upload our class. Thank you very much.